Okay, so most of you got this one right, but to answer this one, if you didn't get it right, or if you're looking for just a faster way of answering this one, the best thing to do is just to count up how many 8s you see, how many 11s you see, and how many 3s you see. You're going to see that there are 7 8s, there are 6 11s, and there are 10 3s. And then just do a quick computation and add these up, and you'll get 152. That'll be the sum of all of these numbers. So it's really just adding all the numbers, but this is a fast way of getting that answer. So this one here, it actually seems really confusing, but if you look at what it's telling you this symbol is, it's actually pretty simple. What the symbol is asking you to do is to essentially round down to the biggest integer that's less than the one in the bracket. So for bracket 6.8, the biggest integer that is less than that number would be 6. For bracket 4.99, I guess I should use double bracket, the biggest integer that is less than that number would be 4. Where it gets a bit tricky is this one here, negative. So the biggest integer that is less than this number, this is where it gets tricky, less than -2 is actually -3. Because if you think of a number line, here's -2, here's -3, here's where -2.1 would be. What's less than that? That way. -3 is the biggest integer that would be less than -2.1. So really all you're doing is 6 times 4 divided by -3, or 24 divided by -3, which simplifies to -8. So this one here was, I think, a little bit confusing in the wording. Even when I read it, I was like, okay, what's it sort of asking? But really what it's asking you is to think about what's the cheapest path, do you think, to get from A to E? That's basically what this is asking you to do. So what you should notice right away is at the moment, this path here is the cheapest path, A, B, E, and it is 340 plus 430, or 770. So we know that we need to be less than that. So if we start looking at some of the other options, for example, if I went A to C to B to E, and I added those, I'm going to get bigger than 770. Or if I went A to D to E, no matter what I do, I'm going to always get bigger than 770. The only one that might have a possibility of being smaller is right there, A to C to D to E. So what we know, A to C to D to E, we know that it's 270 plus 260 plus whatever x is, or 530 plus whatever x is. So what this question is asking you is, what's the biggest possible answer for x that would be cheaper than this one here? So really, if you had 770 take away 530, you'll end up with 240. So if x were exactly 240, they would be exactly the same price. But you don't want them to be the same price. You want this one that I'm doing in green, the ACDE, to be less than the ABDE. It tells you, however, that you must have 10-cent increments. So you couldn't make it like 239. The next closest that you could do for x would be to make it $2.30. That would get you to 760, which would be the cheapest route from A to E. So this one was a bit of a tricky one. It was the one that most people got wrong if they missed one. So one thing to notice, the ABC minus CBA, it has to equal a positive number. For it to equal a positive number and to only have these digits, the letter A has to be greater than the letter C. So this letter here, A, must be bigger than C, or you're not going to get a positive answer. So that's one thing that's really, really important. When you're looking at this, if you look at this sort of column right here, we know that C minus A can be 6, or if you think about carrying, then C minus A plus 10 will be 6, because we could carry the 1 and then it's kind of like 16, right? So if we look at that one, oh, sorry, let me go back for a second. So this one here, C minus A equals 6, is not possible. Why is it not possible? I'm not sure why it's not letting me change color, but it isn't. There. It is not possible because A has to be bigger than C. So you can't take C and subtract a bigger number and get a positive answer. So we know that this has to be the one we're focused on. So when we look at this and we want to try to figure out, let's say, solving for A. To solve for A, we want to add A to this side and add A to this side. So we'll end up with C plus 10 equals A plus 6. And then we want to subtract 6. So basically, we're just solving an equation here. So C will be, sorry, I want, yeah, C plus 4, sorry, will be, that equation is going to be really helpful for you. So now we just sort of start to go through what could A possibly be. So when you start to go through this, you have to realize that A has to be at least, so let me go backwards, sorry. C has to be at least 1, because 1 plus 4. So like if C was 1, A would be 5. If C was 2, A would be 6. So you're now going through the possibilities. If C was 3, A would be 7. If C was 4, A would be 8. And if C was 5, A would be 9. So when you go through all of this, there are 5 possibilities for what A could be. Regardless, each one only has one possible C that might match up with that. So when I'm going through the numbers, C, out of all of my numbers that I could choose, C could have 5, sorry, A could have 5 possibilities. For each value of A that I choose, there's only one C that could possibly be an answer. I have 9 digits that I can choose. So if I'm running out of space here, if I have A, B, and C, I know there are 5 possibilities. Oh, I keep messing that up. I know there are 5 possibilities for A, and each of those has only one possibility. So regardless, I can choose 5 different things right here for A, 5, 6, 7, 8, or 9. Each of them will only have one possible C. That uses 2 of my digits, and I have 9 digits left to choose from. Sorry, I have 9 digits in total to choose from. They have to be distinct. So I have 5 possibilities here, and I have 1 possibility here. That leaves me with 7 more digits that could possibly be for B. To get all of the possibilities, I just multiply those together, and there will be 35 possible combinations of A, B, C. And I know that might have been confusing. I kind of messed up a few times in there, but what was important is that you found this part, went through all of the possibilities for what A could be, and then thought about how many digits were left to choose from for B. All right, this one, a lot of you in looking at your work, were trying to use the formula for a trapezoid. And then we're trying to find like the base 1 plus base 2 divided by 2 times height, and we're trying to figure out all of those things. And then you were trying Pythagorean theorem, and you had different things. So the interesting thing with this, if you just split it, forget about that it's a trapezoid, split it into 2 triangles. So we're going to have this green triangle and not letting me there. And we're going to have this red triangle. And then all you need to do is find base times height divided by 2. So in the green triangle, we have -5 over here. That's our x coordinate. We have -4 over here. So if I went from -4 to 5, I'm going 9 units in total. My height, I went from 2 to 0. That means my height is 2. So for the green triangle, base times height divided by 2, my area would be 9. Now the red triangle, again, I'm still going from -4 over to 5. So this is still going to be my base of my red triangle. My height this time, though, I'm going from 2 up to 6. So now my height is 4. So base times height divided by 2, I get 18 for the red triangle. When I add those together, my total area is 27 units squared.